Hey everyone, welcome back. And today we will be doing another lead code 572 subtree of another tree, an easy one. Given the root of two binary trees, root and subroot return true if there is a subtree of root with the same structure and node values of subroot, and false otherwise. A subtree of a binary tree is a tree is a tree that consists of a node in tree and all this node's descendants. The tree could also be considered a subtree of itself. So we are given two roots, a main root you can say and a subroot. So the subroot should be present. If it is present in our, you can say, main root, then we'll be returning true. And if the subroot tree is not present in our main root, then we'll be just returning false in that case. So this follows almost the same logic as we have done in the problem name same tree. We just compare the trees if they are same or not. So that's it. Like, just say like we'll be making a function like same tree and passing it the root and the subroot. And if at some point, so this is just our exit condition, if not a root and a not a subroot, we will just return true. And if root is valid and the subroot is also there, yes, and the root dot val shall be equal to the subroot dot val, then we want to traverse to the right and left. So this is like self calling the same function like same tree and passing it the root left alongside the subroot left dot left. And yes, I have to put a dot here. Okay. And also a self dot, then again calling the function on the right side. Okay, so self dot, not self dot, but root dot right and alongside subroot dot right, and that's it. So we will just return if none of them is true, like false. If the values are not, you can say, the same or not equals, then we are going to return false. And now what we'll be doing is just calling the function in the main function, but first of all we will check if there is not a root, if there is not a subroot, then basically that root is present, is null and is present in our root at some null point. Like here 5 is pointing to null and 2 is pointing to null, so we will just be returning true in that case. And also if the if the root is not there and the subroot is there, you can say, like, though we will just return false because you can't find the subroot in a null root. So that's it. And if uh, we will say return the self, if none of them is, you can say, like true, then we will first of all do calling the same function, same self dot same same tree, and passing it the root and the subroot. Okay, so if this returns true, then we know that they are the same tree, and if this is not executed, then we know that we have to call the function is subtree to is subtree, because we want to just traverse, you can say, our main root to the left or the right by updating left and right pointers to the left and right nodes. So basically it will be like is sub tree will be passing the root with its left, but the subroot will be the same because we want to check if the subroots like this, if the root will be compared, it will be returning false, so we will just move to the left and see the values are same, and then we will return true because they are basically the same root, the same tree, the same subtree. And if one of them, if we want the value at we want the subtree at the left or the right, if we have already checked, you can say the left, and now we will check the right. So if one of them is true, we are going to return true, so that's why it is an or. So root, right, and the subroot will be the same, and that's it. So let's see if this works or not. Subroot is not defined. Subroot, 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 yes. Okay, R was capital, and that's it.